Hello everyone. So today we'll start with the problems of from the chapter electric force. So the first problem is a negative 5 micron coulomb charge is placed 2 millimeter from a plus 3 micron charge. So find the force between the two charges. So we have two charges given to us. One is negatively charged, which is negative 5 micron coulomb, and the other one is positively charged, which is your plus 3 micron coulomb. The distance between them is 2 millimeter. So for these kind of problems, firstly you need to see the type of force acting on the particular charge. So for example, if I see this negative, we have this negative charge and we have the positive charge here, right? So there is a force of attraction between them. So on this charge, the force of attraction is acting in this direction, and on this charge, the force of attraction will act on this charge. Suppose if I say that at the same time I have another negative charge in this direction, right? So these two charges, they are in contact with each other, like they are near to each other as compared to this third one. So they'll have the force of repulsion between them, right? So on this one there will be the force of repulsion in this side, and it will again feel the force in this direction. Okay, so this is how we can represent the electric force directions on the different charges. So now the force between these two charges, negative 5 micron coulomb and plus 3 micron coulomb, the formula from the Coulomb's law is this: F equals to K Q1 Q2 divided by R square. And whenever you have the micron or nano, you have to convert that. Okay, so K is your 9 times 10 raised to power 9. First charge is negative 5 times 10 raised to power negative 6 coulombs, and the second charge is 3 times 10 raised to power negative 6 coulombs, divided by 2 millimeters. So milli is your 10 raised to power negative 3, and meter is as it is, and when you're gonna solve it, you will get the force of attraction between the two charges equals to this number, 3.38 times 10 to the power 4 newtons. And the force between these two charges is the force of attraction, because we have negative and we have positive charge. If you will have two negative charges, then there will be force of repulsion. If you will have two positive charges, then again there will be the force of repulsion. So note that the signs are used only to determine the force direction. So problem solving strategies for all these problems, firstly just read the problem, draw and label a sketch showing all the given information in appropriate with the SI units. And do not confuse the sign of charge with the sign of force. This is really important, and mostly people get confused with this thing. So attraction or repulsion determines the direction of the forces or the signs. Resultant force is found by considering force due to each charge independently. Again, review the module on vectors if necessary. So for all these electric force, whenever we are applying the force, it's basically we are going to follow all the vector laws in this. So for the forces in equilibrium, the summation of forces on the x-axis will be 0, and the summation of forces on the y-axis will be 0. And we are following all the vector laws, and for a vector quantity we split it in um, x and y components, and we'll do the same thing with the electric force also. So let's do the next example. A negative 6 micron coulomb charge is placed 4 centimeter from a plus 9 micron coulomb charge. What is the resultant force on a negative 5 micron charge coulomb charge located midway between the first charges. So firstly, you need to draw and label your diagram. So if you see, you have three charges given to you. You have plus 6 micron coulomb. So here is your plus 6 micron coulomb is placed 4 centimeter from plus 9 micron coulomb. And here is your plus 9 micron coulomb. And this one is at a distance of 4 centimeter from this one. So now he's saying what is the resultant force on negative 5 micron charge. So this is your negative 5 micron charge placed midway. So if this is at the center, then this distance is 2 centimeter and this distance is 2 centimeter. And you have to find the resultant force on this one, negative 5. So if you see our draw the forces. So after this we are just going to draw the forces. So F1 and F2. So if you see, this is I'll check with a different color. This is my negative, this is again a negative. Okay, so with the negative there will be a force of repulsion from this. Okay, and with this negative here we have a positive, so there will be a force of attraction in this direction. And since we just need to find the total resultant force on this one, so you're just going to find these two forces, the F1 and F2, and you're going to add these two forces then. So this is how you'll find the total net force on the charge negative 5 micron coulomb. Okay, so let's do this. And first force F1, suppose this is between the 6 micron coulomb and this negative 5 micron coulombs. One more important point, when we are talking about the charges, then you're going to take the absolute value of charges in this formula. Okay, so you are taking the sign of the charge only to determine the direction of the force. After that, to calculate the magnitude of force, you will take only the absolute value of the charge. So this way, and the distance between them is 2 centimeter, you're going to convert that to meter. When you'll solve it, you will get F1 equals to 675 Newton. And then for the F2, you will have it with 9 micron coulomb and negative 5 micron coulomb. And on solving, you will get F2 equals to 1013 Newton. So now you got the magnitude of this, you got the magnitude of this. Now, since both the force vectors, they are in the same direction, so we are gonna add these two forces. Okay, so this is the law of the vector addition. If you have both the forces in same, you will add that, and if you have one in this direction and the other in the other direction, then you subtract them. So now since they both are in the same direction, we'll add them, and your F1 is this, F2 is this, so the resultant force will be the sum of each independent force, and we will get, by adding these two numbers, plus 1690 Newton. So that is the total resultant force acting on negative 5 micron coulomb. Now the next example is that three charges Q1, Q2 and Q3, they are arranged as shown below, and find the resultant force on negative 4 micron coulomb. So again we'll draw the free body diagram for this, and for that you need to find the total number of forces acting on this charge. So if you just see this negative 4 micron coulomb, so there are basically two forces acting on it. One is from Q1 and the other one is from the Q2. and since they both are positive charges, so this will get the force of attraction between them. So it is having one this force, Q3 is getting one force in this direction according to Q2 because of Q2, and one in this direction because of Q1. So these are the two forces, F1 and F2, acting on this charge, and you can also find this angle between these by using the right angle triangle law. So note the directions of the forces F1 and F2 on Q3 based on attraction and repulsion from Q1 and Q2. So this is what I showed you in this one. Now, so again, you got the direction of the forces for the F1 and F2, and now we are just gonna apply the Coulomb's law, and the K Q1 Q2 divided by R square. So F1, for the F1, for this force, you have these two charges plus 8 micron coulomb and negative 4 micron coulomb, and they are separated by 5 centimeter. So, and for the F2 we have 6 micron coulomb and negative 4 micron coulomb, and they are separated by the 3 centimeter, and we need to find the resultant of these two forces also. So now the F1 is, when you'll calculate this, the direction of the F1 is 115 Newton, the magnitude is this, and the direction will be 53.1 degree to the south, and the F2 is 240 newtons to the west. So if you see the vectors, so if this is your origin, okay, and if I draw my coordinate frame like this, it goes like this. Here is your x, here is your y, and F2 is going on the negative x axis. So here is your F2. So this F2 has no y component and it is going in the direction of the west, whereas your F1, the F1 vector is somewhere here. This is having magnitude 115 Newton and it is in a direction of with this 53.1 degree south of the west. So now once you have these components, so now you need to review your vectors and how you can find the total resultant of these two vectors. So if you see these two vectors, so you have one F1 and F2. So F1 is this one and F2 is 240. So F2, and then after that to find the total resultant of these, so what they have done, they have split the vectors in the components. So in again, if I'll show you, my F2 is here and F1 is here. So F2 is on the x-axis, it has only the x component, and whereas the y component is 0. So this thing is done, and it is on the negative x, so it is with a negative number. Now the F1 vector will be having F1 y and it will be having some F1x components. So F1x is again on the negative x-axis, so we are getting negative for this. So F1x, this is how we find it, negative F1 cosine of with the theta, and F1y will be negative F1 sine of theta. So you got these two numbers, you got these numbers. So once you have all the x components and you have all the y components, you can find the resultant of the vector. So resultant of the vector will be, you're gonna take the summation of all the x components and summation of all the y components. So on the x-axis we have negative 69.2 and negative 240. So you're gonna take these two negative numbers, you will add them because they both are acting on the same negative x-axis line. So the R of x is negative 92.1 Newton, and R of y is your negative 69.2. So you got these two numbers, negative 240 and this. So once you will have the x and y component, you can find the total component of your I guess they took the different yeah, these are the right numbers for the x and y components of R. And once you have the components, you can find the total resultant vector, which is gonna be your under root rx square plus ry square. So once you have the components, you can find the total magnitude of the vector, and the direction will be given by theta equals to tangent inverse y component over the x component. So you got the magnitude of the vector and you got the direction of the vector as well. So this is the total resultant force acting on the charge which was situated at this point. Thank you. So the summary of the formulas, like all the like charges, they will always repel, and all the unlike charges, they are gonna attract each other. This is the Coulomb's law, the Coulomb's force, which we used in all the examples. And K is a constant, which is 9 times 10 to the power 9 Newton meter square per Coulomb square. For all the microns, you're gonna take 10 raised to the power negative 6. For the nano, you will take 10 raised to the power negative 9. Pico is 10 raised to the power negative 12. The charge on one electron is this, negative 1.6 times 10 to the power negative 19